Hey YouTube, first video since my return. I wanted to talk to you about this project. Looks kind of ominous, but all it really is a prop laser pointer. It's scaled up from one of those itty-bitty little tiny keychain laser pointers, which I can't seem to find the one I use as a scale reference, but all it really is this PVC tube, and inside, a whole bunch of components mounted on this carriage. Now, this is actually my first experience with using a milling machine, which we just got at the Hack Lab, so it's actually pretty fun. I managed to mill out a whole bunch of custom components on the inside here, which worked out quite well. But I figured I'd just kind of go through all the internals here. I'm going to zoom in here for you. Alright, so, what do we got here? Starting from this side, this is the battery compartment. I built this with only one of these ringed plates so that I can mount any size battery pack depending on how much current I need. Turns out I actually need a decent amount for such a bright LED, so I'm glad I gave myself the extra space. Now, these are also all milled out internally, so I can get airflow through the whole assembly. I've got this eBay special DC to DC converter, which I'll hold up for the camera here. Alright, so the QS1235 CCBA 100 watt. All it really is a constant voltage and constant current power supply. So I've got my 12 volt or whatever voltage power coming from my battery, going through the constant current power supply, which gives my LED a constant current, so that even if the battery voltage is changing, I can still get consistent output through here. Now, I've also put a small 12 volt fan, slightly modified to fit in the dimensions I need, to blow air across the heatsink. Now, without the fan, the heatsink will get pretty hot, but in a worst case scenario of zero airflow, at full power, the entire assembly hits a passive thermal temperature of 51 degrees Celsius after a bit of extensive testing, just letting it sit there slowly cooking and worrying that my expensive LED is going to blow up. Fortunately it didn't, but the fan just helps kind of keep it cool. Then I've got this lens up here. Put that in view here for everyone. This lens I ended up saving out of a surplus pile. This, I think, if you eBay or Google the part number here, it's a Theta 1428. This guy actually comes with like a film projector, so it expects a virtual image, however many distances back at a certain focal point to project that image out forward. Yeah, so this is the lens, and it's expecting a image to be further back so it can project an enlarged image out front. I discovered this when I actually took a flashlight with an emitter just like this guy. You see a little 4 LED dye pattern there. I actually saw this dye pattern, including all the little tiny bridge wires inside. All these little tiny bridge wires projected on the wall across my shop, and I thought, hey, it'd be really cool if I could do something like a gobo projector in a tube. Unfortunately, because of the optics and the power necessary, I'd opted to turn this into a prop laser pointer. So, getting on with it. Film projector lens with a custom bracket plate here. This bit's interesting, actually. I ended up trying to take the original bracket, which the outer circumference of this bracket and the inner circumference where the lens actually sits, they're not concentric. One was actually offset by a good amount, and it proved very difficult to slide this in and out of this tube assembly. So what does that mean? I tried to grind it down. Then I ran into some difficulty grinding it down, and then I tried milling it down also to make some slots for these threaded rods, which the whole thing's assembled with. Turns out, I think this is actually magnesium. It's too heavy to be aluminum, it's too light to be steel, it's too hard to be aluminum. Like, a center punch barely touches it, but unlike aluminum, it doesn't clog up a grinding wheel. So that only leaves so many metals, magnesium being one of them. It had amazing thermal conductivity from one side to the other. Nearly instantaneously when I was grinding, I could feel the heat of the grinding transfer through the entire ring of material through into my hands. I ended up using a vice grip to get this thing so I didn't burn my hands holding this against the grinder. But unfortunately, this just proved to be too difficult, so I ended up 3D printing out of ABS plastic my own mounting ring. Then I discovered that my optical pattern was, well, shit. So I ended up having to pull a Hubble telescope here. You'll see up here there is another lens assembly. This is actually just a convex magnifying lens that I actually picked up from the dollar store, of all things. I took the magnifying glass, used some side cutters, and liberated the glass element, and just held it and tried to figure out the distances. Unfortunately, because this is a multi-diameter, it's actually very hard to get good-looking optics and have a diffuse circle projected out any distance. And because of that, unfortunately, it also means that I have to try and just move the lens as close as possible to the LED to capture as much of the light. This might change a little bit because I have another idea that a friend suggested, actually. But regardless of which, I pulled a Hubble telescope, put a corrective lens in front of this entire assembly, and it actually works okay. So I'll probably cut in a clip of the end result. But once I slide this assembly back in, and unfortunately I'm lacking the correct size drill bit to drill this out to the perfect diameter so it slides easily. Come on, you bugger. I'm on camera here, but I'm going to ramble a little bit. I figure that one of the real pains of doing my old videos was just the time and effort it took. I actually had this old Canon S5IS, which shot 4:3 standard definition video, and it was all the greatest thing back in the day. But since then, cameras have proceeded to become cheaper and better, and I ended up investing in this camera. It's actually an NX5U from Sony. So, professional camera, or at least entry-level professional. Decent image, solid build, no more problems for me. It should be a lot easier for me to get videos, plus I'll be less fiddly with the cuts and edits. So anyways, corrective lens out front does an okay job. But one of my friends who actually does a whole bunch of telescope and other optics in the past, he suggested a Fresnel lens. And we're back. So, Fresnel lenses. I ended up picking up this Fresnel lens from good old Princess Auto up in Canada, the Canadian equivalent of Harbor Freight. One of these 3x sheet magnifiers. Oh, you can actually see the magnification on camera there. That's all fancy. Whatever this NK brand is. It's some made in China company out of Brooklyn. Regardless, it's either acrylic or probably more likely polycarbonate. Pretty durable, pretty flexible. But I'm going to have to take this and mount it inside a spare set of 3D printed assembly rings that I have, and mount it in front, or I can mount it between the variable lens assembly and the LED, so that I can take more of the light coming out of this, turn it into a parallel beam, shove it through this lens, correct it with that lens, and hopefully I can get even more lumens from this. And the LED itself is actually 1200 or so lumens, so rambling on a bit, but that's the state of that. As for the battery side, I'm actually using a lithium polymer battery. I've put an Anderson power pole connector on the end of this. I've got my battery charger running in the background while I've been filming this and other videos, so there you go, project update for the prop laser pointer. Should be a pretty interesting build.